last class we studied about geometric diagram. Then there are various types of diagrams are there. We studied geometric diagram, in that one a simple bar diagram, then multiple bar diagram, then pie chart. These things we studied. Today we can study about histogram. What is a histogram? Then a histogram, actually before that, frequency diagram. Then what is frequency diagram? Data in the form of grouped frequency distribution are generally represented by frequency diagrams like histogram, frequency polygon, frequency curve and OGIVES. Okay. Then if it is in a frequency distribution, then we can take that measurement in a frequency distribution like 1 to 5, 5 to 6, like that. We can make some class and we can make it as a frequency distribution. And in the case of frequency diagrams, histograms, we are using histograms, frequency polygon, frequency curve and OGIVES. Okay. Then what is histogram? A histogram is a two-dimensional diagram. Then a histogram is a two-dimensional diagram. It is a set of rectangles with base as intervals between class boundaries, x-axis, and with areas of proportional to the class. Means frequency distribution we will mention in x-axis, and class frequency, here this is the class frequency and this is the frequency distribution. This one we will mention in x-axis, this area we will mention in x-axis, and this frequency in y-axis. Okay. Then generally the rectangles are proportional. Then we know in bar diagram also we are doing same thing, but one difference is there. In bar diagrams normally we will leave some gap. Okay, in between this we will leave some gap. In this case histogram we are not leaving any space. Okay, that is the difference. Okay, here you can see, then a histogram means you can see rectangles lying parallel to the baseline and of the same magnitude to be drawn a vertical distance equal to frequency of the class interval. Here you can see, depends on frequency of class interval, we will draw the vertical line. This is the histogram. In the case of histogram, it looks similar to bar diagram, but there are more difference than similarities between histogram and bar diagram. Okay, it may appear at the first impression like bar diagram only, but the spacing and the width or the area of bars are arbitrary. Means suppose sometimes what in bar diagram, if you are taking, here we studied bar diagram. Okay, if you are taking this bar diagram, see, we know here we are leaving some space. Okay, that is the difference. But in this case histogram, what we are doing, we are doing it continuously, because we are taking like 44.5 to 49.5. Next class is 49.5 to 54.5, 54.5 to 59.5, 59.5 to 64.5. Like that we are taking the classes. Okay. Then here also you can see on bar diagram, we know these bar diagrams are separate bars. Okay, but in the case of this one, we know this is the histogram. This one is the histogram. In this case, here you can see 1 to 3, 4 to 6, means it is continuously coming. That reason 1 to 3 up to here, then 4 to 6 up to here, then it is 7 to 9. That one is the histogram. Okay, then draw a bar for each interval. The height of the bar is the frequency of the interval. Here you can see 1 to 3 it is 15. Then we can mark here 15 will come here. Then we can mark here. Next one 4 to 6 is 17. You can mark 17. Next one is 7 to 9. 7 to 9 it is 16. We can mark this one. This is the simple bar diagram. Okay. Then this is the difference. Sorry, this is the histogram. Okay. Then difference is that this is the bar diagram. This is multiple bar diagram, boys and girls. Okay. That reason we are calling it as multiple bar diagram. Separate bars are there. Here you can see histogram. This is the histogram. Okay, then we studied about histogram. Then we know for frequency distribution, we are representing through different frequency diagram like histogram, frequency polygon, frequency curve, and OGIVES. Now we can study about frequency polygon. What is frequency polygon? Here you can see frequency polygon. Frequency polygon is the most common method representing for a grouped distribution. Okay, both class boundaries and class mark can be used along x-axis. The distance between class mark and two classes will be proportional, and the width of the class intervals will be equal. Okay, plotting of the data becomes easier if the class mark fall on the heavy lines of the graph paper. Okay, here you can see the classes like 44.5 to 49.5, 49.5 to 54.5, 54.5 to 59.5. For this one we need to find out the midpoint. Okay, we need to find out the midpoint, and what we need to do means we need to mark that midpoints. Here is the midpoint for 44.5 and 49.5. Here is the midpoint. Then here is the midpoint. Like that we need to mark the midpoints, and after that we need to join these points. That one is the frequency curve. Okay, frequency polygon. That one we are calling as frequency polygon. Then what is frequency polygons? Midpoints are used in this frequency polygon. When all the points have been plotted in the graph, they are carefully joined by a series of short straight lines. Okay, we will mark all the midpoints, and what we will do? We will mark all the midpoints and we will join carefully these midpoints. Broken line joins midpoints of two intervals, one in the beginning and other in the end. Okay, then here in beginning they start from here. Okay, not from this point. Beginning it will start from here, and the end it will join in x-axis. Okay, that is the specialty of frequency polygon. Then we need to start from 0 and need to mark the midpoints, and we need to join these midpoints very carefully. That one is the frequency polygon. Okay, then for a frequency polygon, first we need to draw like these bar diagrams, then histogram. From that one we need to find out the midpoint, then after that we need to join this midpoint, then we can get the frequency polygon. Okay, then next one is frequency curve. What is frequency curve? The frequency curve is obtained by drawing a smooth freehand curve passing through the points as closely as possible. Here how we are drawing? With a scale we need to join very carefully. That one is the frequency polygon. But in the case of frequency we need to join these points with hands, means we need to take the midpoints like this, means we need to find the points. After that we need to pass that points with the hands. Okay, it may not necessarily pass through all the points of the frequency polygon, but it passes through them as closely as possible. Okay, we need to draw the points and we need to pass this line. Okay, then this one is the frequency curve. This is the frequency curve, and here you can see the frequency curve. This is the frequency curve. Okay, this dotted line is the frequency curve. Okay, next one, ogive. Ogive is also called cumulative frequency curve. Ogive is cumulative frequency curve. Then there are two types of cumulative frequency, less than type and more than type. More than cumulative frequency and less than cumulative frequency, that one we studied already. Accordingly, there are two ogives for any group frequency distribution. Two types of ogives are there. Then in the case of frequency polygon, cumulative frequencies are plotted on y-axis against class limit. Okay, for less than ogive, cumulative frequencies are plotted against respective upper limit of the class intervals, whereas more than ogives, cumulative frequencies are plotted on the lower limit of the class interval. Okay, then for less than, we are using upper limits. For more than, we are using lower limit of the class. Then when we are joining these less than ogives and more than ogives, we will get a diagram. Okay, you can see here less than ogive, this is the less than ogive, this is the more than ogive. When we are plotting in a same graph, you can see you will get a midpoint. This is the median. Okay, this point is the median. Okay, when we are joining less than ogives and more than ogives, we will get a midpoint. That one is the median. Okay, here you can see number of students and frequency distribution. Okay, first upper limit, which one is the first? We can find out the less than ogive. How we can find out? First upper limit, which is the upper limit? For less than, we will take upper limit. Then first we need to write less than 20. What is the frequency? 6. Okay, then next one, less than 14, upper limit 40. Then next step is less than 40. Then we need to add this 2. 6 plus 5, it is 11. Okay, then here already 6 is there because up to 26 is there. Then 6 plus 5, it is 11. Next one, less than 60. Then here already what is the value? 11. 11 plus 33, it is 44. Okay. Next one, less than 80, 44 plus 18. 44 plus 14, it is 58. Next one, 58 plus 6, it is 64. Less than 100. Okay. Then we got the less than values. Next one is more than values. We need to start from lower limit, more than 0. Then we need to take the total. More than 0, how many frequencies are there? Means up to 100 it is there. We know more than 0, how many frequencies are there? Up to 100 frequencies we need to take. Then we need to take the total of these numbers. Total is 64. Then more than 60. Next one, more than 20. Then we need to subtract this 64 minus 6. Then we will get 58. Okay. Next one, less than. More than 40 means what is the value here? It is 58. 8. Okay, here what is the value? 58. We need to subtract from 58, we need to subtract this value. Okay, 58 minus 5, it is 53. Okay, then next one we need to subtract 53 minus 33, it is 20. Next one, 20 minus 14, it is 6. Okay, then we got the more than values also. Okay, then here we need to take 0, a lower limit, 0, 20, 40, 60, 80. Then for more than cumulative frequency, we need to take the lower limit. For less than cumulative frequency, we need to take the upper limit. Okay, this one how we can draw, we can study in next class.